Welcome. In this video, we're going to cover the properties of logarithms, which extend from the properties of exponents. So I'm assuming that you're already familiar with the properties of exponents, especially negative exponents. I'm not going to teach negative exponents. I'm assuming that you're already aware that 2 to the negative third power is 1/8, and consequently then that log base 2 of 1/8 equals -3. I'm not teaching what logarithms are, I'm teaching what you can do with them, so you should be familiar with how logarithms relate to the exponential. I mean, logarithms are the inverse of exponentials, just like addition is to subtraction in the same way that exponentials are to logarithms. But anyways, there are a few properties of exponents I want to highlight here because they correspond to the properties of logarithms we're going to learn today. Usually there's just 3 of them. I'm going to throw in one more. But anyways, the first property of exponents I want to remind you of is, right, if I am multiplying 2 exponential expressions with the same base, I would add the exponents. So realize here that multiplication outside of the exponent corresponds to addition inside the exponent. If we reverse that around, or rather invert that, and we would have log base 2. If we have log base 2 of x plus log base 2, I say base b, any base of y, is going to equal log base b of x, y, or x times y. So again, notice the connection here. Multiplication outside the exponent corresponds to addition inside the exponent. Addition outside the logarithm corresponds to multiplication inside the logarithm. So very similar here. We also have that if we divide 2 exponential expressions, we would subtract the exponents, right? So division outside of the exponent corresponds to subtraction inside the exponents. Same idea here. If I'm subtracting 2 logarithms, log base b of x minus log base b of y, this is going to be, or can be written as, log base b of x over y. So subtraction outside of the logarithm implies division inside the logarithm. Then if we have a power to a power, like b to the x to the y, this means we can multiply the exponents. Similarly, if I have an exponent inside the logarithm, I can actually multiply that to the front. So see how this a used to be in the exponents, now it's in front right here. You can do that. Good. These are the main 3. When you hear the phrase properties of exponents, this is what they're talking about. I'm going to add in one more, which ironically isn't actually applicable to this video, but it's good for you to know. Remember that anything to the 0th power is 1, right? Anything to the 0th power has a value of 1. Flip that around. Log base b of 1, any base, log any base of 1 is going to equal 0. So again, I don't think we actually use that in this video, but there you go, the more you know. So good. I'm going to spend some more time on the properties. If you want to get straight to the work, the lesson, you can skip to example 1, but here I'm calling this example 0, understanding the properties, and I want to connect the properties to exponents. So here, right, 2 squared times 2 cubed equals 2 to the 5th. Really, the moral of the story here is that 2 plus 3 equals 5. It's a game of exponents, and we just used, right, this is making use of this property of exponents right here. And I want to show you how it relates to logarithms, how it relates to the corresponding property of logarithms. So let's see here. 2 plus 3. Well, if we were to force logarithms into this, what is 2 as a logarithm with base 2? It'd be log base 2 of 4. So stop and think about that real quick. Log base 2 of 4 is 2. I'm going to do the same thing with 3. 3 would be log base 2 of 8, right? Essentially 2 to the third power equals 8, right? So I'm just rewriting this with logs. Now, if I apply this first property that I brought up, this one right here, this says that addition outside the logarithm means I could multiply inside the logarithm. So I could actually multiply this 4 and this 8 and write it as a single logarithm. So log base 2 of 4 times 8, which is 32. Okay, so remember, this is asking you 2, I'll just write it over here, 2 to the what power equals 32. 2 to the what power equals 32, and the answer is 5. And sure enough, 2 plus 3 equals 5. We just took the long way there using the first property of logarithms. This used the first property. All right. Here, similar situation, kind of the moral of this story right here is that 5 minus 3 equals 2. So let's walk through this. Let's go the long way. Let's walk through the properties of logarithms. 5, well, we can steal that from the previous problem. 5 is log base 2 of 32. Log base 2 of 32 minus 3 is log base 2 of 8. All right, good. And let's apply the second property of logarithm from the beginning, which says, right, if I have subtraction outside the logarithm, that corresponds to division inside the logarithm. So we're going to divide the 32 and the 8. Log base 2 of 32 divided by 8, which is log base 2 of 4. And log base 2 of 4 is 2. And sure enough, right, 5 minus 3 is 2. There should be no surprise there. But that is the second property of logarithm. And then here we go. We have the third. Here, the moral of the story is 2 times 3 equals 6. And we'll see that this is consistent through the third property. So 2 times 3, 2 times 3. I'm only going to rewrite the 3 as a logarithm this time. So we have 2 times log base 2 of 8. Again, if it feels a little weird, all I'm saying is that log base 2 of 8 is 3. So I can substitute that out. Now, my third property says this number in front is no different than having an exponent on that 8, right? It could go either way. This is the same. According to the third property, this is the same as log base 2 of 8 squared, right? So this 2 became an exponent on the 8. And again, in other problems, if you want to take it off the exponent and put it in front, you can do that. That's just not the direction we're headed right now. Anyways, 8 squared is 64. And so we're asking ourselves, 2 to the what power is 64? 2 to the what power is 64, and the answer here is 6. As expected, 2 times 3 is 6. So here we see how all three properties of logarithms relate to the corresponding exponential properties. It's all connected, they're just inverted. Okay, example 1, and if you're familiar with my videos, the way they work is there's a my turn, your turn. So I'm going to do a problem, and then I'm going to pause and let you do the other version. So again, it's recommended that you have pen and paper out, pencil and paper out, and that you're participating and not just watching. But, you know, obviously you do what you want to do. The solutions to all of this is in the description. There's a link in the description so you can check your answers. Also, my penmanship will be better on there if you want to study later. Anyways, expand. Example 1, expanding logarithms. So this is something we can do with the properties. We can take a single logarithm and we can expand it. So And then we're going to simplify when possible. So realize here that 9x, well, 9x is 9 times x. And in property 1, right, this is using property 1, we said that multiplication inside the logarithm corresponds to addition outside the logarithm. So we can split this up from 1 log, right? Here's 1 log. We've split this up into 2 logs. Simplify when possible. What is log base 3 of 9? That is 2. So 2 plus log base 3 of x is going to be your answer. Good. Pause the video. Try this one. You can check your answer in the PDF in the description. Next one. This is using the second property of logarithms, which states that division inside the logarithm corresponds to subtraction outside the logarithm. So again, I can split this up with a minus sign in the middle. Simplify when possible. What is log base 5 of 125? That is going to be 3. So we have 3 minus log base 5 of z. That is your answer. Try this one. Okay, this is going to make use of property 3, which says I can take this exponent right here and I can multiply it out front. So my next step is to do just that. 4 log base 2 of 8. Simplify when possible. What is log base 2 of 8? That's going to be 3. So this is 4 times 3, which is 12. And the answer is 12. Try this one. Okay, now we're just going to mix and match them and get a little bit bigger as we go. So this is, well, all things in the parentheses here are being multiplied. It's 2 times y times z. Now, this is not a step that you need to write down. I'm just reminding you that 2yz means 2 times y times z. So this could break into 3 logarithms. Log base b of 2 plus log base b of y plus log base b of z. And so you have split, you have expanded this single logarithm into 3 logarithms, all connected by addition. And that's it. That's really all there is to do there. That's the answer. Try this one. All right, this one's going to make use of property 1 and property 2 because we have a multiplication and a division. So this is going to equal log base 5 of 7r. I'm going to do this in 2 steps. You could do this in 1 step. But 7r minus log base 5 of s, right? All I'm doing here is I'm turning the division inside the logarithm into subtraction outside the logarithm. Now this right here, this is still 7 times r. So I can split this up even further. We'd have log base 5 of 7 plus log base 5 of r minus log base 5 of s. That is the answer. And if you see that from the beginning, right, this middle step here is optional. If you want to go straight from the beginning to the end, totally acceptable. Go ahead and try one on your own. Here we go. Yes, another thing I'm going to take for granted in this video is that you can go between exponential notation and radical notation. So just a reminder here, the square root of x is the same thing as x to the 1/2 power. So this is the same thing as the natural log of x to the 1/2 power. And then we apply property 3 from the first page, which says I can take this exponent and I can multiply it out front. So this is the same as 1/2 ln of x. A couple things. All the properties that we've done applies to ln, just as it does any other logarithm, right? What is ln? Remember, ln is the logarithm with base e. So it is a logarithm. All the properties of logarithms still apply to it, all the same. Another thing, up here I put parentheses around the s. Here I did not put parentheses around the x. Same thing, totally optional. If there's just a single variable inside the logarithm, you do not necessarily need parentheses. With or without, totally fine. Go ahead and try this one on your own. You can check your answer in the PDF below. Example 2, we're still expanding logarithms. I'm just going to turn it up a bunch. And remember that x to the negative n power, I don't like that x to the negative n power is 1 over x to the n, right? We're going to use that a lot here. Okay. Expand the following logarithmic expression. So first thing I want to do here is I want all my negative exponents to be positive, right? So the a to the negative 2, that needs to go to the bottom. And the b to the negative 1 needs to come to the top, right? So it's an issue of reciprocation. The negative exponent sends that one down, and the negative exponent sends that one up. Good. So now we have some division. We have division in the logarithm, and this corresponds, right, to subtraction outside the logarithm. I don't need parentheses yet. So essentially all I've done is I've split the numerator from the denominator via subtraction. And then now I need to split the a squared times b cubed with multiplication. So the first step used property 2, the second step used property 1. And then I'm going to do 2 steps in one here. I'm going to finish the problem right now. 2 things are going to happen. I'm going to use property 3, which means I can take that exponent and multiply it out front. I can take that exponent and multiply it out front as well. And I'm also going to distribute the negative. I'm also going to distribute the negative. This gives me a final answer of log base b minus 2 log a. Sorry, not base b, just log of b minus 2 log a minus 3 log b. And that right there is the answer. So connecting this to the almost beginning, connecting this to back up here, right? This 2 ended up in front. This 3 ended up in front. And the logarithm with the a inside of it was a negative because it's in the denominator, and the logarithm with the b, whoa, I made a mistake. With the c, this right here should have been c. Also ended up with a negative because it was in the denominator, right? So everything that's in the numerator ends up positive, and everything that's in the denominator ends up negative. That's the connection. Anyways, that's the answer. Go ahead and try this one. All right. Here we go. Let's play around, right? We're going to play around with the exponents first before I apply any of the properties. So first things first, I have this x to the negative fifth right there. So I'm going to write that as y squared over x to the fifth. And then I have this cube root right here. As an exponent, that's going to be 1/3 to the 1/3 power. There's a couple different ways you could do this. I'm going to start by just multiplying my exponents here. Right, this was the third property for exponents on the front page. So this would be the same as log base b of y to the 2/3 over x to the 5/3. Now, using property 2, the division turns to subtraction. We'll have a log, let's see if I can fit this, log base b of y to the 2/3 minus log base b of x to the 5/3. All right, benefits of an iPad here. Scoot that over. And then I'm going to apply property 3, which states that I can take this exponent and multiply it to the front of the logarithm. I can do the same thing with that exponent right there. So this gives me a final answer of 2/3 log base b of y, optional parentheses, minus 5/3 log base b of x. And that's the answer. Try this one. Oh, this is going to be exactly like what we just did. I want to rewrite all my roots as exponents. The square root of a is the same as a to the 1/2. And the fourth root of x cubed is the same thing as x to the 3/4, right? Then if we apply property 2 of logarithms, we can split this up over subtraction. And then if we use the third property, we can multiply all those exponents to the front. And that's it. That's all you got to do. Again, optional parentheses. In the previous problem, I put parentheses around the variables. Here, I did not. As long as there's a single variable, it doesn't matter. Go ahead and try this one. All right. I'm going to rewrite everything with exponents, no radicals. We got a squared is already good to go. Then b to the 1/3, c to the 1/2, d to the 3/2. Okay. The PDF in the description has very detailed solutions. But I also want to show you how you can go straight from the beginning to the end. I'm going to do this in one step. I'm going to do the entire problem. Well, in 2 steps. I guess I already did 1 step. But here's what's going to happen. All the exponents are going to be multiplied to the front of their respective logarithm. And all the variables that are in the numerator are going to be in a positive logarithm, while all the variables in the denominator are going to be in a negative logarithm, right? Because multiplication corresponds to addition, but division corresponds to subtraction. So the answer for this is 2 log A plus 1/3 log B minus 1/2 log C minus 3/2 log D. And you can do that. Right, that just used all three properties in one step. If I lost you there, look at the solutions. I show every single step. Try this one. All right, example 3, condensing logarithms. So we're gonna go the other way now. We've been taking a single logarithm and expanding it out into multiple. Now we're gonna be given multiple logarithms and we're gonna have to rewrite them as a single logarithm. So condense the following logarithmic expressions, simplify when possible. We have addition outside the logarithm that corresponds to multiplication inside. So I can take this 3a squared c and multiply it by the 7a cubed c to the 5th. Right, this just used property 1, but in reverse, if you will, the other way from what we've been doing. So log base b, multiply everything. 3 times 7 is 21. A squared times a cubed is going to be a to the 5th, and c times c to the 5th is going to be c to the 6th power. And there you go. You've taken two logarithms and you've rewritten them as a single logarithm. That's the answer. Go ahead and try the next one. Here we're going to use property 2 in reverse. We have some subtraction going on outside the logarithm, and this corresponds to division inside the logarithm. So we just divide the 2a to the 5th and the 4a squared. 12 divided by 4 is 3, and a to the 5th divided by a squared is a to the 3rd. Just like that. Try the next one. All right. We're going to use all three properties on this one. This minus right here means there's going to be some division. This plus means there's going to be some multiplication. And we can take all these numbers in front and make them exponents inside the logarithm. So the 2 is going to go to the m, the 2/3 is going to go to the n, and the 5 is going to be the power or the exponent of p. So let's do that first. Let's make all the numbers in front exponents inside. That's a 2/3. P to the 5th. All right, so that was property 3 in reverse. Good, this minus right here is going to correspond to division. I'm also going to rewrite this end of the 2/3 in radical notation. So we'll have ln of m squared on top, and then cube root of n squared on the bottom. And then we're going to multiply this p to the 5th for a final answer. Let me scrunch a little more room here. I'll write it right here. So the p to the 5th is going to join the m squared up top. And then we have our cube root of n squared in the bottom right there. That is the answer. So we took 3 logarithms and we wrote them as a single logarithm. Try the next one. Okay. See, we have an extra layer of parentheses right here. So we want to deal with this first. Sorry, here we go. We want to deal with this first. Log 3 plus log 4. Now that is addition, so we can multiply the 3 and the 4. This is going to give us log 7 minus 1/3 log, and 3 times 4 is 12. Then we can take that 1/3 and make it the exponent of 12. So we have log base 7 minus log, not log base 7, log of 7. The base here is 10, right? The base here, that's worth saying. The base here is 10 when there isn't a base. It's understood to be 10. Anyways, 12 to the 1/3 power. And then subtraction is going to correspond to division. So log of 7 divided by, and I'm going to write this as the cube root of 12. And unfortunately, none of this can be simplified. We're just going to leave it like this. Try the next one. Example 4, evaluating logarithms. Use the properties of logarithms to evaluate the following expressions without a calculator. Okay. What is log base 2 of 1/16? In other words, 2 to the what power equals 1/16? -4 plus 1/2. What is log base 2 of 4? In other words, 2 to the what power equals 4? That's going to be 2. -4 is 4. Half of 2 is 1. The answer is 5. Isn't that crazy, right? This whole thing right here, that whole thing equals 5. Try this one. All right. What is log base 4 of 1/16? Wait, the instructions here are to use the properties of logarithms. We didn't use any properties in the previous problem. Interesting. Okay, let's actually use the properties here. So now you're going to see that these can be done two ways. All right, first thing is I have this 2 out front. If I use the property, that means I can make it the exponent of the 4. So I would have log base 4 of 1/16 minus log base 4 of 4 squared. Okay. Now this right here, this is subtraction outside the logarithm, so we can divide inside. So we're going to have log base 4 of 1/16 divided by 4 squared, which is log base 4. I had to think about that for a minute. Why I just paused is I was evaluating that in my head, right? 4 squared is 16, and then 1/16 divided by 16 is going to give us 1/256. Okay, all right. So now, what is log base 4 of 1/256? That is going to be -4. And again, what just happened? That's because 4, I'm going to write it over here, that's because 4 to the -4th power is 1/256, right? That's why the answer is -4. But okay, great. So you see the difference here between the first one that I did. I really didn't do this one the way the instructions said, but it can be done that way. It can also be done this way. So try them both. Be aware of how to do both. Go ahead and try this one. I'm going to go back to doing this one the first way we did it. Just why not? We get variety, right? What is this is a new one right here. We haven't seen something like this yet today. Log base 4 of 2. Right? This is essentially asking 4 to the what power equals 2. 4 to the what power equals 2. It's going to be the 1/2 power, or in other words, the square root, right? The square root of 4 equals 2, but we're going to use that as 4 to the 1/2 power equals 2. 4 to the 1/2 power equals 2. So this first piece here is 6 times 1/2 plus. In the previous problem, we saw this. We have a similar situation here, except it's not a fraction, so this is going to be a positive 4. Positive 4 over 2 times, what is log base 4 of 16? Well, that's just 2. Half of 6 is 3, plus 4 over 4, or 3 plus 1, which is 4. Answer is 4. Go and try this one. Let's go back to using the properties of logarithms. I may regret this. I need a calculator. All right, let's see what happens here. We're in this together. I'm going to go ahead and make the 3 the exponent of the 1/5, the 2 the exponent of the 1/25. So that gives me log base 5 of 1/5 to the 3rd power plus log base 5 of 1/25 squared. Nothing happens here. Which is log base 5 of, let's see, 1 over 5 cubed is going to be 1 over 125. 1 over 25 squared is going to be 1 over 625. Nothing happens with the last one. Okay. So I'm going to knock 2 steps out in one. Addition corresponds to multiplication and subtraction corresponds to division. So I could write this as log base 5. All right, let's see what we got here. We're going to have 1 over 125 times 1 over 625 divided by, okay, it's not as bad as I thought, 125. And then we could just go ahead and cancel out these 1 over 125s, right? That's nice. Those are going to cancel out. So we're just left with log base 5 of 1 over 625. And, okay, so 5 to the 4th power is 625. So this is going to be 5 to the negative 4th power equals 1 over 625. All right, the answer here is negative 4. Okay, great. So not exactly the way I would do this if I was given freedom, but if we are to apply the properties of logarithms, this is how it would get done. But again, look from the beginning here. What is log base 5 of 1/5? That's just going to be negative 1 plus 2 times, what is log base 5 of 1/25? 1 over 25. That's going to be negative 2. And then minus, what is log base 5 of 1 over 125? That's negative 3. So we have negative 3 here. Let's see, let's evaluate the thing that I have on top here. That's negative 3 minus 4 plus 3, which equals negative 4, right? So yeah, it does, right? That's funny. Would you rather do it this way or this way? I think I know the answer, but be aware it can be done with the properties of logarithms. I recommend that you try this one using those properties just to see how it all connects. Example 5, logarithmic equations. Use the properties of logarithms to solve the following equations. So good. We're just going to give you a little taste of this. There's a lot more you could do, but we'll keep it simple for now. Here we have addition outside the logarithm. Right by now, you should be like, oh, I need to multiply inside the logarithm. Yes, you're correct. That is exactly what you need to do. So log base 6 of 2x minus 2 times x plus 2 equals 2. Okay, pause. We're now going to use the fact that log base b of x equals y is... Oh, I want to keep the... No, stay with me. I'm stuck in a loop. Dang it. All right. Log base b of x equals y is the same thing as saying b to the y equals x. We're going to use that here, but on a slightly larger scale. That is 2x minus 2 times x plus 2 equals 6 squared. So all I've done is I switched from the logarithm to the exponential, just in the context of an equation here. All right, good. Let's go ahead and distribute all of this. We have 2x squared minus 2x plus 4x minus 4 equals 36. I'm going to knock out 2 steps in one here. First thing I'm going to do is I'm going to do negative 2x plus 4x. I'm also going to bring the 36 over to the other side. This gives me 2x squared minus 2x minus 40 equals 0. Now notice that all of these numbers here are divisible by 2. So I'm going to go ahead and divide out of 2 from the entire equation, which we can do because 0 divided by 2 is still 0. We have x squared minus x minus 20 equals 0. This factors to x. Ooh, these should have been positives right here. Positive, positive. Good. X plus 5, x minus 4 equals 0. All right, I need some room. Which these give me two solutions of x equals negative 5 and x equals 4. So good, my apologies if you got lost, right? All of this here was factoring. So that's not, we're not teaching that in this video. If you need to brush up on how to solve via factoring, do so. Now we have two solutions here. And if this right here was the original problem, like if all of this, we didn't start with the logarithm stuff, these would be the answers. However, we have to remember that we're in the context of logarithms, and logarithms have restrictions, kind of like a square root, right? Where you can't have negatives. Well, you can't have anything non-positive in a logarithm. So that doesn't mean that the negative 5 itself is wrong because it itself is negative. But what the issue here is, right, if x equaled negative 5, then let's look at this piece right here, this second piece, the second logarithm. Then log base 6 of x plus 2 would be log base 6 of negative 3, right? Because I'm just plugging in the negative 5 right here. Negative 5 plus 2 is going to give you that negative 3. And so again, it's not the negative 5 that's the issue as much as it is the negative 3 that's the issue. We can't have negatives inside logarithms, at least not in the realm of real numbers. You're starting to get to imaginary stuff there, and we're not doing that right now. So we're actually going to throw out the negative 5, and there's only one answer here. The answer is 4. These are called extraneous solutions, solutions that pop up in a different context, but we have to remember that the ultimate context here is the logarithms. So we really only keep one of the solutions. The -5 is an extraneous solution. Try this one. Okay, here, similar situation, but we have a minus this time, so we are going to turn this into division inside the logarithm. So we have log base 5 of x plus 1 over x minus 3 equals 1. And then I'm going to go ahead and change this to the corresponding exponential equation, which would be x plus 1 over x minus 3 equals 5 to the first power. I want to multiply both sides by x minus 3. That's going to cancel these out. Cancel, cancel. We'll have x plus 1 equals 5x minus 3. Go ahead, distribute. I'm going to subtract the x to this side. I'm going to add the 15 to this side, which gives me 4x equals 16 for a final answer of x equals 4. We get 4 again. All right, good. There's no extraneous solution here. That's it. The 4 is the answer. Totally fine. Go ahead and try this one. Last thing I'm going to address is the change of base formula right here, and this allows us to rewrite any logarithm as the ratio of two other logarithms with the base of our choosing. So here, one problem, and then we're done. Rewrite the following logarithms as a ratio of logarithms with base 10. So right here, this has a base of 7. But if for whatever reason you really wanted to have a base 10, actually, here's a reason you might want base 10. Some calculators don't give you an option of base. Like if you were to evaluate this in a calculator, some calculators won't. Some calculators won't let you do a base of 7. So the way you can get around this is doing log base 10 of 19 divided by log of 7. Remember, if I don't write a base here, I did not put a 10 here. I didn't put a 10 there. It's understood. It's the common logarithm. So that's it. That's all you got to do right there. Try this one. And then we're done. So thank you for watching this. Hoped it helped. Grammar. Okay. So this is it right here. This is the lesson. These properties right here. This is what you want. Be comfortable with those. Memorize them if you have an exam on them. All right. Thank you for watching. We'll see you next time.